Hi, welcome to Upward Bound Math Analysis Day 3. Today we're talking about exponential and logarithmic equations. First, let's start with the basic exponent log rule. If you have the log base b of x and it equals y, the y is actually the exponent, the b is the base, and the x is the answer. So the argument here becomes the answer here in exponential form. This is a list of your exponent rules. You will need to keep this handy so that you can reference it, so that you can simplify things easier. This is a list of your log rules. They're very similar to your exponent rules. They have a lot of the same characteristics, like when you multiply, you really add, or a power to a power, so on and so forth. So, exponential equations with like bases. In an exponential equation, the variable is in the exponent, and there may be more than one exponential term, or more than one, like 3 to the 2x plus 1 minus 5 is equal to 4, or 3 to the x plus 1 is equal to 9 to the x minus 2. If you can isolate terms so that the equation can be written as two expressions with the same base as the equations above, then the solution is actually simple. So example 1, 3 to the 2x plus 1 equals minus 5 equals 4. Clearly isolate the exponential expression first and rewrite the constant in terms of the same base, so that you have 3 to the 2x plus 1 is equal to 3 squared. Then you can simply set the exponents equal to each other, drop the bases, and solve the problem, so that in this case x would equal 1/2. In this expression, 3 to the x plus 1 is equal to 9 to the x minus 2. Again, we're going to rewrite the 9 as 3 squared and distribute that 2 to the x minus 2 so that we get 3 to the x plus 1 is equal to 3 to the 2x minus 4. Once they're in the same base, you can drop the bases. You can solve the exponents so that x is equal to 5. Exponential equations with different bases is when you need log functions to evaluate them. So when you have 3 to the 2x plus 1 minus 5 is equal to 11, or 3 to the x plus 1 is equal to 4 to the x minus 2, we're going to solve both of those. So again, you're going to isolate the exponential equation. You're going to take the log or the natural log of both sides. Okay. Use the log rules that let you rewrite the exponent as a multiplier and then solve that expression. So when we isolate the variable, we take the natural log of 16 divided by the natural log of 3, subtract 1, and then divide by 2. That will give us our answer as x is approximately 0.762. Same kind of problem, take the natural log of both sides because they're already isolated. Drop the exponents down front, that's one of your logarithmic rules. Okay, and then solve that. Again, you need to isolate the variables, so get all the x's on one side and all of everything else on the other. Divide, and then use a calculator to actually calculate the decimal value of a negative natural log of 3 plus 2 times the natural log of 4, all divided by the natural log of 3 minus the natural log of 4. You get x to be approximately 13.457. In this problem, in a logarithmic equation, the variable can be inside the log function or inside the base of the log function. There may be one log term or more than one. For example, when we have log base 4 of 2x minus 1 plus 3 is equal to 5, or the natural log of x minus the natural log of 2x plus 1 is equal to 1, or the log base x of 3 is equal to negative 2. So first problem, Isolate the logarithmic expression, so subtract 3 from both sides. Then you're going to rewrite it in exponential form. 4 squared is equal to 2x minus 1. Solving that, sorry about that, solving that, you get x is equal to 8.5. Example 2, we had the natural log, and the natural log is base e. It's log base e, and e is a number. So you do isolate the log expression, convert into exponential equation, where here the base is e. Again, get all the x's on one side, solve for x, distribute the e, and then collect x terms and factor out the x by division. You do get an x value of negative 0.613. Finally, that last example, the log base x of 3 is equal to negative 2, so x to the negative 2 is equal to 3, raised both to the negative 1/2 power. Can't go around with your radical down, so be sure that you rationalize that denominator. Thanks for watching.